Why is Earth likened to a giant spaceship, traveling through the cosmos at unimaginable speeds? From its rotation and revolution, to its wild dash around the Milky Way with the Sun, and its journey toward mysterious gravitational sources deep in the universe, lies a grand cosmic law, known as universal gravitation. Gravity keeps Earth perpetually in motion through two forces: revolution and rotation. Earth rotates around its axis from west to east, at a speed of approximately 0.46 kilometers per second, equivalent to 1,670 kilometers per hour. This velocity far exceeds the 900 kilometers per hour of commercial airliners. It is precisely this motion that creates Earth's day-night cycle, based on modern astronomical observations and calculations. Earth's orbital speed is about 29.79 kilometers per second, traveling an average of 2.57 million kilometers daily. Over the course of a year, its total journey spans roughly 940 million kilometers. Can be said that our Earth is perpetually racing through the cosmos at every moment. Today, aboard this cosmic spacecraft called Earth, we shall journey together to explore this mysterious universe. We often perceive the ground beneath our feet as solid and stable, as if it were an eternal anchor point in the cosmos. Yet this sensation is an illusion, a grand illusion confined to the human scale. In truth, we do not exist motionless within the universe. Each of us is an eternal astronaut, residing aboard a colossal spaceship called Earth. This vessel has been sailing for over 4 billion years. It is not docked in a harbor, but hurtles silently through the void of cold interstellar space, at speeds far beyond ordinary imagination. Imagine this scene. As Earth performs its basic rotation, you stand on the equator. Even if you stand perfectly still, you are moving at over 1,670 kilometers per hour. This speed exceeds that of a rifle bullet leaving the barrel, and is nearly twice the cruising speed of a commercial airliner. Yet this represents merely the slowest, most subtle motion of this spacecraft. As Earth orbits the Sun, our velocity surges to 29.79 kilometers per second. This equates to traversing over 2.5 million kilometers daily along our orbital path, a distance sufficient to make 3 round trips between Earth and the Moon. But this spacecraft's journey extends far beyond. Our entire solar system is pulled by the gravitational pull of the Milky Way. The Sun, our stellar pilot, guides Earth and its siblings at a staggering 220 kilometers per second. As we race around the Milky Way's center, 30,000 light-years away, this speed exceeds Earth's orbital velocity by more than 7-fold. Even so, this journey is not the final destination. Our galaxy itself participates in a grander cosmic migration within the universe's gravitational web. It hurtles toward a mysterious gravitational abyss, the Great Gravitational Source, in the constellation Hydra, toward a mysterious gravitational abyss known as the Great Attractor in the constellation Hydra. This ultimate velocity is 2.7 times the Sun's speed around the galactic center. From hundreds of meters per second in rotation to hundreds of kilometers per second in galactic migration, Earth, this spaceship, engages in multiple complex motions simultaneously. We are nested within the dynamic structures of the cosmos, from a single planet to a stellar system, then to a galaxy, a local group of galaxies, ultimately to a supercluster spanning 500 million light-years. Each layer of structure is in motion, each layer of motion governed by a fundamental cosmic force. In the journey ahead, we shall unveil the quadruple motion trajectories of Earth, this cosmic spacecraft, from the most intimate rotation and revolution to the solar system's swift journey through the Milky Way, and finally, the grand voyage of the Milky Way toward its ultimate gravitational destination. We will explore the unified cosmic laws behind these motions, understand how gravity weaves this invisible web of motion, and reconsider our role aboard this precious vessel. Now, please fasten your seatbelts. Our interstellar voyage is about to begin. The stable gravity we feel beneath our feet is the fundamental force sustaining the Earth's spacecraft in its voyage. It is an invisible cosmic tether, governing everything from falling apples to the motion of galaxies. In the late 17th century, Sir Isaac Newton first glimpsed its universality. Legend has it that a falling apple inspired him to realize the force pulling objects toward the ground and the force keeping the moon in Earth's orbit are fundamentally the same force. He called it universal gravitation. The law of universal gravitation states that every object with mass in the universe attracts every other object with mass. The strength of this attraction is directly proportional to the product of their masses, and inversely proportional to the square of the distance between their centers. This is a concise and elegant mathematical formula, yet possesses the immense power to explain celestial motion. According to this law, objects with greater mass exert stronger gravitational pull. This is why the Sun firmly controls the entire solar system, as its mass accounts for 99.86% of the system's total mass. Its immense gravitational field acts like an invisible vortex that binds the 8 planets, countless asteroids, and comets to their respective orbits. Yet gravity diminishes sharply with distance, following the precise mathematical relationship of the inverse square law. It is precisely this weakening with increasing distance that allows planets to maintain stable orbits without spiraling into the Sun or being flung into the cold interstellar void. Newton's law of universal gravitation proved extraordinarily successful. It precisely predicted celestial positions, calculated Halley's Comet's return, and even guided human probes to the moon and beyond. Yet Newton's theory was not flawless. It failed to perfectly explain Mercury's slight precession at perihelion, nor elucidate how gravity itself traverses empty space to exert its action at a distance. This puzzle remained unsolved until the early 20th century, when another genius provided an answer. Albert Einstein provided us with a completely new perspective on the universe. In his general theory of relativity, gravity is no longer a force in the traditional sense, but rather a geometric effect arising from the curvature of spacetime itself. Imagine the fabric of the universe as a vast, flexible rubber sheet. When an object with mass is placed upon this sheet, it causes a depression. This depression is the curvature of spacetime. The greater the mass, the deeper the depression. Massive celestial bodies like the Sun press a deep crater into the fabric of spacetime. Earth and other planets orbit along this curved spacetime structure, their paths resembling a marble rolling along the rim of a crater. They follow the shortest path within the curved spacetime, what we call a geodesic. This motion, as we observe it, manifests as the orbital path around the Sun. Einstein's general theory of relativity not only resolved the Mercury precession puzzle, but also made numerous astonishing predictions. For instance, gravity bends light rays. When light from distant stars passes near the Sun, its path undergoes a minute deflection. This phenomenon was confirmed during the 1919 solar eclipse observation, propelling Einstein's theory to instant fame. Another pivotal prediction is gravitational time dilation. In strong gravitational fields, time slows down. This effect now finds everyday application through the global positioning system. Without relativistic corrections, GPS positioning errors would accumulate over 10 kilometers daily. From Newton's inverse square law to Einstein's geometry of spacetime, our understanding of gravity has undergone profound transformation. Yet their core principles remain consistent. Gravity is the architect and navigator of the cosmos. It shapes the large-scale structure of the cosmos. It drives gas and dust to condense into stars and planets. It causes galaxies to cluster into vast superclusters. It sets the fundamental rules for cosmic navigation. As Earth hurtles through space, it is not actively pushed or pulled by some mysterious force. Instead, it follows the geodesic path of spacetime curved by the sun's mass. Moving inertially, this is a natural glide, much like a sled sliding down a slope along its predetermined terrain. The motion of the solar system around the Milky Way follows this same principle. The immense mass at the galactic center, primarily the supermassive black hole 4 million times the sun's mass, and the densely packed stellar region surrounding it, collectively warp spacetime on galactic scales, creating the immense gravitational potential well that sustains the solar system's orbit. Meanwhile, the Milky Way's own hurtling toward this colossal gravitational source is driven by the cosmic scale warping of spacetime, induced by the Laniakea supercluster, a structure of unimaginable mass. Gravity, this invisible cord, though far weaker than the other three fundamental forces, ultimately governs the universe's grand design and motion through its ability to act over infinite distances and accumulate effects. Ultimately governs the macrocosmic features and motion laws of the universe. It is both the force binding us to Earth and the ultimate engine propelling this cosmic vessel through a series of intricate and magnificent voyages across the cosmos. Only by understanding gravity can we truly begin to decipher the profound physical language behind the Earth spacecraft's voyage log. The most fundamental motion of Earth, this cosmic spacecraft, is its ceaseless rotation. It spins rigorously from west to east around an imaginary axis piercing its north and south poles. This rotational direction is not arbitrarily set. It determines why we always see the sun rise in the east and set in the west, and establishes the fundamental flow of the global time system. The speed of Earth's rotation is a staggering figure. At the equatorial surface, its linear velocity reaches 465 meters per second. Converted to a more intuitive concept, this equates to 1,670 kilometers per hour. This speed surpasses the cruising speed of most modern passenger aircraft, and approaches 1.4 times the conventional definition of the speed of sound, though it remains slightly below the top speed of hypersonic strategic reconnaissance aircraft. Remember, this represents merely the surface-level motion of the Earth spacecraft. It is a velocity you passively acquire simply by standing still. The spacecraft's hull carries you along in this silent, high-speed rotation. Yet Earth's angular velocity is uniform and steady, completing a full rotation approximately every 24 hours. This stable rotational rhythm serves as our natural benchmark for measuring time. But how can one prove to a passenger inside the spacecraft that the spacecraft itself is rotating? In the 19th century, French physicist Léon Foucault designed an elegant and compelling experiment. Under the dome of the Pantheon in Paris, Foucault suspended a heavy pendulum measuring 67 meters in length. The lower end of the pendulum was fitted with a pointer, and a layer of sand was spread beneath it. When the pendulum began its continuous oscillations, observers noted that its plane of oscillation did not remain fixed. Instead, it slowly rotated clockwise over time, completing one full rotation approximately every 32 hours. This phenomenon arose from no external force. Its only plausible explanation was the Earth's rotation beneath the pendulum. The Foucault pendulum directly demonstrated that our planet is a non-inertial rotating reference frame. This experiment is now displayed in science museums worldwide, silently narrating the fact of Earth's rotation. The most direct and vital consequence of Earth's rotation is the alternation of day and night. When one side of the Earth faces the sun, that region is bathed in sunlight and experiences daylight. Meanwhile, the opposite side, turned away from the sun, sinks into its own shadow and enters night. This ceaseless cycle is not the result of the sun revolving around the Earth. It is precisely the clear evidence of the Earth's own rotation. This periodic cycle of light and darkness has profoundly influenced life on Earth. It sets the biological rhythms of the vast majority of living organisms, the so-called biological clock. Plants regulate photosynthesis and respiration accordingly. Animals schedule hunting and hibernation in sync. Even human physiology and social activities bear the deep imprint of this 24-hour rhythmic cycle. The profound impact of Earth's rotation extends far beyond creating day and night. It fundamentally shapes the very form of our spacecraft. The centrifugal force generated by rotation is strongest at the equator and nearly negligible at the poles. This has caused the redistribution of Earth's mass over vast geological time, resulting in a slight bulge at the equator and a slight flattening at the poles. Measurements indicate Earth's equatorial diameter is approximately 43 kilometers longer than its polar diameter. This makes Earth not a perfect sphere, but a slightly flattened ellipsoid. We call this Earth's oblateness. This slight difference in shape directly influences the distribution of Earth's gravitational field. The gravitational force you experience at the equator is slightly weaker than at the poles. Furthermore, Earth's rotation generates a phenomenon that appears mysterious yet is critically important: the Coriolis force. This force is not a genuine interaction, but rather an inertial effect exhibited by objects moving within a rotating reference frame. Its direct manifestation is that objects moving in the northern hemisphere deflect to the right, while in the southern hemisphere they deflect to the left. Although the Coriolis force cannot alter an object's velocity, it continuously changes its direction of motion. This effect is particularly pronounced in large-scale fluid movements, dominating the patterns of global atmospheric circulation and ocean currents. Within Earth's atmospheric circulation, the Coriolis force is pivotal in forming the trade wind belts and prevailing westerlies. It causes warm air from low latitudes to deflect as it moves toward the poles, shaping the global climate zones. Within weather systems, the Coriolis force's influence is more immediately apparent, as it determines the rotation direction of cyclones. Cyclones and typhoons in the northern hemisphere always rotate counterclockwise, while those in the southern hemisphere always rotate clockwise. In the oceans, it similarly influences the paths of ocean currents, enabling the formation of large-scale oceanic circulation systems. Form vast circulation patterns, such as the North Atlantic Gyre. These circulations play a crucial role in the global transport of heat and matter, thereby regulating the Earth's climate, from shaping planetary forms to influencing global climate patterns, from establishing temporal benchmarks to guiding storm trajectories. Earth's rotation is far from a simple physical concept. It is one of the most fundamental and dynamic processes, shaping the internal environment of our spaceship. It transforms the Earth spacecraft from an inert vessel of navigation into a vibrant, ever-changing cradle of life. After completing countless rotational cycles, the Earth spacecraft also silently progresses along a grander orbit, its revolution around the Sun. This marks our spacecraft's complete journey around its primary star, the Sun. Earth's orbital path is not a perfect circle, but an exquisitely precise ellipse, with the Sun positioned at one of its two foci. This discovery stems from the monumental work of astronomer Johannes Kepler, who revealed the first law of planetary motion. The distance between Earth and the Sun constantly adjusts as it moves along its orbit. When Earth reaches its closest point to the Sun, the perihelion, the distance between them is approximately 147 million kilometers. At this point, Earth receives the most concentrated solar radiation. Conversely, when Earth moves to its farthest point from the Sun, the aphelion, this distance expands to 152 million kilometers. The 5 million kilometer variation in their distance may sound astronomical, but it actually represents only 3.4% of the average distance. This minute variation alone is insufficient to produce the seasonal cycles we experience on Earth's surface. The truly dramatic shift determining seasonal transitions stems from the convergence of two more critical factors: Earth's orbital motion itself and the tilt of its rotational axis. Earth's rotational axis is not perpendicular to the plane of its orbit. Instead, it maintains a stable tilt of approximately 23.5 degrees. This tilt is known as the obliquity of the ecliptic. It is one of the core elements shaping Earth's climate patterns. Imagine as Earth moves along its orbital path, its axis of rotation remains fixed in space, always pointing toward the vicinity of the North Star. This causes the Sun's zenith point to oscillate between the tropics of Cancer and Capricorn, as Earth progresses through different positions in its orbit. When the Sun's zenith point reaches the Tropic of Cancer, the northern hemisphere receives sunlight more directly, gaining greater solar energy per unit area. Simultaneously, daylight hours reach their annual peak. This phase marks the onset of summer in the northern hemisphere. Meanwhile, the southern hemisphere experiences oblique sunlight, with shorter days and reduced energy intake, thus entering winter. As Earth traverses the opposite side of its orbit, the Sun's zenith point shifts toward the Tropic of Cancer, causing the seasons in the northern and southern hemispheres to completely reverse. This dance of light and energy distribution, orchestrated by the Earth's axial tilt and its orbit, is the true origin of the seasonal cycle. It determines the growth cycles of plants, the migration patterns of animals, and the fundamental rhythms of human agricultural societies. The Earth's orbital path is not fixed, under the subtle gravitational perturbations of other planets. It undergoes a series of complex periodic oscillations. These minute variations in orbital parameters are known as the Milankovitch cycles. They exert profound and pivotal influence on Earth's long-term climate evolution, particularly the alternation between glacial and interglacial periods. The Milankovitch cycles primarily encompass three astronomical factors. First, variations in Earth's orbital eccentricity, whose value oscillates between near-circular and more flattened elliptical orbits, with a cycle of approximately 400,000 years. Greater eccentricity means more significant differences in solar radiation received at perihelion and aphelion. The second factor is the variation in the Earth's axial tilt. Its range fluctuates between 22.1 degrees and 24.5 degrees, with a cycle of about 41,000 years. A steeper tilt typically results in more pronounced seasonal contrasts. The third factor is the Earth's precession. Similar to a spinning top, the slow wobble of its axis, the direction of Earth's rotational axis in space, slowly traces a cone-shaped path over a cycle of approximately 26,000 years. Precession alters the specific season in which perihelion occurs. For instance, around 11,000 years ago, the northern hemisphere's winter coincided precisely with perihelion, resulting in relatively milder winters at that time. Today, northern hemisphere winters align with aphelion, theoretically making them colder. Individually, these subtle orbital variations, their effects are negligible. but when they overlap with different cycles, they can alter the total amount and distribution of solar radiation reaching Earth, particularly the summer sunlight in high-latitude regions of the northern hemisphere. When summer sunlight remains persistently low, snow melts less readily and accumulates year after year, eventually reflecting more sunlight and causing further cooling of the Earth. This could become the key trigger for an ice age. The multiple glacial and interglacial cycles documented in the geological record exhibit a striking correspondence with the periods of the Milankovitch cycles. This demonstrates that even our seemingly stable orbital path itself undergoes profound natural pulsations. Earth's average orbital velocity reaches 29.79 kilometers per second, equivalent to 107,000 kilometers per hour, and an astonishing 2.57 million kilometers per day. This velocity is sufficient to circle the Earth's equator 7.5 times within a single second. Despite advancing at such high speed, Earth still requires exactly 365.256 days to complete one full orbit around the Sun. This forms the astronomical basis for our definition of a year, the total distance Earth travels annually along its orbital path amounts to approximately 940 million kilometers. This figure represents a scale almost beyond imagination. It signifies that our Earth spacecraft travels over 60 times its own diameter daily through interstellar space. All this occurs under the precise guidance of gravity, silently accomplished within the near vacuum of the cosmos. The relative stability of its orbital path is one of the cornerstones enabling Earth to become a cradle of life. It maintains a perfectly balanced distance from the Sun, neither too close nor too distant, positioned within the so-called habitable zone. This allows Earth's surface temperatures to sustain liquid water over vast stretches of time, and liquid water is precisely the essential medium for the chemical reactions of life as we know it. The periodicity of Earth's orbit provides a stable, predictable temporal framework for the evolution of life and the birth of civilization. Like a grand cosmic pendulum, it measures the passage of time with precision, recording the countless life stories and geological transformations carried by the Earth spacecraft in its endless cycle around the star. From shaping the seasons to influencing millennia-long climatic cycles, from defining time to sustaining life's continuity, Earth's orbital motion stands as the most rhythmic, brilliant movement in the spacecraft's voyage log. As we immerse ourselves in the rhythms of Earth's rotation and revolution, a grander navigational panorama unfolds around us. This Earth spaceship does not traverse the interstellar vacuum alone. It is a member of the vast fleet that is the solar system, and the core and navigator of this entire fleet is our Sun. As a typical yellow dwarf star, the Sun's powerful gravity governs the vast expanse within a radius of 1 light-year. It does not hover motionless in the cosmos, but carries all the matter of the solar system, including the 8 planets, countless asteroids, comets, and interstellar dust. At a staggering speed of 220 kilometers per second, it orbits the distant center of the Milky Way galaxy in a periodic revolution. This velocity exceeds the Earth's orbital speed by more than 7-fold, meaning we traverse a distance equivalent to 7 Earth diameters every second. The solar system's position within the Milky Way is not at its center, but rather along a secondary spiral arm known as the Orion Arm. This arm lies approximately 26,000 light-years from the bulge at the galaxy's center. This distance places the solar system within the Milky Way's habitable zone. It keeps us distant from the lethal intense radiation zone near the galactic center, while allowing access to sufficient heavy elements from ancient stars to form planets and support life. Given the Milky Way's immense scale, a single orbit of the solar system around the galactic center requires an immense amount of time. This cycle is defined by astronomers as a galactic year, lasting approximately 250 to 270 million Earth years. This timescale transcends the history of human civilization and serves as a natural unit for measuring cosmic time. Calculations indicate our solar system formed roughly 4.6 billion years ago, from the moment it ignited nuclear fusion to become a star and cleared its surrounding protoplanetary disk. It embarked on this protracted journey around the Milky Way. Calculated thus since its birth, the solar system has completed roughly 18 full revolutions around the galaxy. We now stand midway through the 18th galactic year, or at the dawn of the 19th. These 18 galactic orbits are not mere repetition. Each galactic year bears witness to profound transformations of Earth and the solar system. In geological history, the span of a galactic year is sufficient for a supercontinent like Pangaea to undergo fragmentation and reorganization, and for Earth's life forms to evolve from simple prokaryotes into complex multicellular organisms, while enduring multiple complete reshuffles of the biosphere. The famous Permian-Triassic mass extinction event occurred as the previous galactic year drew to a close, while the asteroid impact that ended the dinosaur era 66 million years ago took place in the early stages of our current galactic year. The solar system's orbit around the Milky Way is not smoothly planar. Through long-term observation and calculation, astronomers have discovered that while orbiting the galactic center, the solar system also performs periodic up and down traversal movements, perpendicular to the galactic plane. Viewed from the side of the galaxy, its trajectory forms a graceful undulating curve, resembling a giant vessel navigating the cosmic seas. The cycle of this undulating motion takes approximately 62 to 64 million years to complete a full oscillation. This implies that roughly every 30 million years, the solar system crosses the galactic plane. The galactic plane is the region of highest material density in the Milky Way, where greater concentrations of stellar gas and dust clouds gather. When the solar system periodically traverses the galactic plane, its surrounding space environment undergoes significant changes. The density of interstellar matter increases. Cosmic ray intensity may fluctuate, though these changes have negligible direct impact on Earth itself. They may induce significant gravitational perturbations in the Oort cloud at the solar system's outer edge. The Oort cloud is a vast spherical shell, composed of trillions of icy celestial bodies at the solar system's outermost reaches, considered a reservoir for long-period comets. When the solar system traverses the galactic plane, and its gravitational environment is influenced by other galactic matter, the stable orbits of icy bodies within the Oort cloud may become disrupted. Some of these bodies could be ejected into interstellar space, while others might plunge inward toward the inner solar system, becoming the long-period comets we observe. Some astrobiologists and paleontologists have noted that the timing intervals of certain mass extinction events in Earth's history appear to correlate to some degree with the periodicity of the Sun's transit across the galactic plane. They hypothesized that periodic increases in comet impact rates may be one factor driving cyclical major crises in Earth's biosphere. Although this hypothesis requires further evidence to confirm, tightly links the fate of life on Earth to the grand motions of the solar system within the Milky Way, demonstrating the profound impact of cosmic-scale events on a single planet. The Sun, as our fleet's navigator, sets the course and pattern of our voyage, determining the spatial environment experienced by the entire solar system within the Milky Way. From cruising at 220 kilometers per second to traversing the galactic year every 250 million years, to crossing the galactic plane once every 30 million years, These movements, seemingly eternal by human standards, have shaped the history of our solar system and may have subtly influenced the evolutionary trajectory of life on Earth. We follow the Sun, our guiding vessel, traversing the vast Milky Way along a predetermined spiral orbit, overlaid with vertical undulations, toward an unknown galactic future. Our journey with the Sun as navigator through the Milky Way does not unfold in a uniform, empty space. The Milky Way is a barred spiral galaxy, with distinct spiral arms and highly uneven material distribution. This means the external cosmic environment experienced by Earth's spacecraft undergoes periodic changes as our position within the galaxy shifts. Though slow and protracted, these shifts may leave an indelible mark. An indelible mark, the orbital velocity of the solar system around the galactic center, is not synchronized with the rotational patterns of the spiral arms. Astronomers believe the spiral arms are density waves, similar to traffic congestion zones on highways. Stars and interstellar matter periodically enter and exit the arms. Current research indicates the solar system traverses a major spiral arm approximately every 50 to 60 million years, such as the Sagittarius arm or Perseus arm. The interstellar regions within these arms are active stellar birthplaces in the Milky Way, harboring a concentration of young, massive stars, giant molecular clouds, and interstellar dust and gas. As the solar system, carrying Earth as its spacecraft, traverses these arms, we first encounter a significantly elevated density of interstellar matter. Though these diffuse nebular materials are extremely sparse, theoretically, they may exert a compressive effect on the heliopause, the boundary where the solar wind meets the interstellar medium. Undergo some compression, although this compression effect itself may have negligible direct impact on Earth's internal climate. The more significant influence stems from potential changes in cosmic ray flux. Cosmic rays are high-energy particle streams originating from deep space, primarily composed of atomic nuclei, traveling through the cosmos at near-light speeds. Their sources include supernova explosions and violent astronomical events like active galactic nuclei. The spiral arms of the Milky Way galaxy are hotspots for these high-energy events. When the solar system traverses a spiral arm, Earth may be exposed to a higher background radiation level of cosmic rays. Although most of these high-energy particles are blocked by Earth's atmosphere and magnetic field, their collisions with atmospheric molecules produce secondary particles including muons and neutrons. These may also promote the formation of aerosol nuclei in the atmosphere. Some climatological hypotheses link variations in cosmic ray flux to variations in low-level cloud cover on Earth. The theoretical mechanism posits that cosmic rays ionize the atmosphere, potentially aiding in the formation of more cloud condensation nuclei, thereby increasing global low-level cloud cover. Low clouds reflect more sunlight back into space, exerting a cooling effect on Earth. If this mechanism holds true, then the periodic traversal of the solar system through the galactic spiral arms, leading to periodic increases in cosmic ray flux, may indeed correlate temporally. The geological record indeed shows that, over the past hundreds of millions of years, Earth has experienced 4 major glacial periods, roughly spaced 1 to 1.5 million years apart. This timescale bears a thought-provoking correspondence to the frequency with which the solar system traverses half its orbit around the Milky Way, that is, crosses a spiral arm. Beyond the periodic influence of spiral arm crossings, the solar system's passage through the galactic plane, every 32 to 64 million years, constitutes another significant environmental cycle. The galactic plane is the midline plane of the Milky Way's disk structure. Here, not only are stars and matter denser, But the gravitational environment is also more complex. When the solar system oscillates vertically and crosses the galactic plane, its gravitational field is disturbed by the vast amount of matter within the galactic disk. Though these gravitational disturbances are extremely faint, their effects propagate through gravity to the distant Oort cloud. The Oort cloud, the outermost region of the solar system, is a vast spherical shell composed of trillions of icy celestial bodies. It functions as a comet reservoir, storing vast numbers of long-period comet nuclei. As the solar system crosses the galactic plane, the gravitational pull of galactic matter may act like an invisible hand, gently nudging these distant icy bodies, disrupting their stable orbits, causing some comets to be flung into interstellar space, while others are directed toward the inner solar system, forming a comet shower. Some of these intruders from the solar system's frontier may collide with planets in the inner solar system. Paleontologists David Lopp and Jack Sepkoski, analyzing marine fossil records, discovered that over the past 250 million years, Earth's mass extinction events appear to follow a quasi-periodic cycle of approximately 26 million years. This cycle aligns remarkably closely in timescale with the solar system's orbital precession through the galactic plane. This gave rise to a renowned scientific hypothesis, the galactic precession comet impact hypothesis. This theory posits that the solar system's periodic crossing of the galactic plane, triggering a shower of comets from the Oort cloud, which increases the probability of Earth being struck by large comets or asteroids, thereby causing periodic mass extinction events. The most famous example is the Cretaceous-Paleogene extinction event, 66 million years ago, that ended the age of dinosaurs. An asteroid or comet approximately 10 kilometers in diameter struck what is now the Yucatan Peninsula in Mexico. The timing of this impact event coincides precisely with a cyclical interval of galactic plane crossing, providing strong support for this hypothesis. Beyond the physical threat of comet impacts, changes in the galactic environment may also exert more subtle influences. Periodic intensifications in cosmic ray flux could not only influence climate, but their inherently high radiation levels might directly impact Earth's biosphere. Though Earth's magnetic field and atmosphere shield us from most cosmic rays, geological history reveals multiple periods of magnetic field weakening or even reversal. During such intervals, encountering galactic spiral arms or cosmic ray peaks from the galactic plane, surface radiation levels could rise significantly. This heightened background radiation might accelerate the rate of genetic mutations in organisms, thereby influencing the pace and direction of biological evolution on a macro scale. It could either provide more raw material for natural selection, speeding up the formation of new species, or exert survival pressure on certain sensitive species, potentially becoming a catalyst for mass extinctions. Placing Earth's life story within the grand context of the galactic environment reveals a far more complex picture. Earth is not a completely isolated ecosystem, sheltered within the solar system. It navigates the Milky Way alongside the Sun. Yet this galactic ocean is not perpetually calm. Spiral arms resemble periodic storm zones. The galactic plane resembles shipping lanes concealing hidden reefs. Fluctuations in cosmic ray intensity. Periodic increases in comet impact probability. These faint pulsations from the depths of the Milky Way, accumulating and amplifying over vast spans of time, may ultimately trigger dramatic climate shifts and biosphere transitions. On Earth, this cosmic vessel, this profoundly reveals how distant yet profoundly interconnected galactic scale events are, with the most minute life forms on a single planet our existence, is both a product of Earth's own environmental evolution and a byproduct of the solar system's long voyage through the Milky Way. Understanding this connection enables us to grasp more profoundly the preciousness and fragility of Earth's spaceship within the cosmos. Our solar system is a complex, layered celestial system whose vastness far exceeds common imagination. Its boundaries extend far beyond Neptune's orbit, to a staggering distance. The solar system's territory can be divided into several distinct regions from innermost to outermost. The innermost zone is the remnant region of the solar system's formation, primarily composed of 4 rocky planets. Mercury, the closest planet to the Sun, is pockmarked with craters and experiences extreme temperature swings between day and night. Venus is shrouded in thick sulfuric acid clouds and a carbon dioxide atmosphere, where the greenhouse effect makes surface temperatures hot enough to melt lead. Earth, our familiar arc of life, features liquid water, habitable temperatures, and a stable atmosphere. Mars is a red desert planet, boasting the solar system's largest volcano and deepest canyon. Beyond Mars' orbit, between Mars and Jupiter, lies the asteroid belt. Contrary to sci-fi depictions, it isn't densely packed with tumbling boulders, but scattered with numerous small bodies and dust particles, widely spaced apart. The asteroid belt is a remnant of primordial material that failed to coalesce into planets during the solar system's early formation. It stands as a fossilized ring recording the infancy of our solar system. Beyond the asteroid belt lies the outer realm of the solar system's giant planets. Jupiter reigns as the undisputed king of the solar system. Its mass is 2.5 times that of all other planets combined. A gas giant, it possesses no solid surface and is primarily composed of hydrogen and helium. The famous Great Red Spot is a colossal storm system that has raged for centuries, large enough to swallow several Earths. Saturn follows closely behind, renowned for its magnificent and intricate planetary ring system, composed primarily of countless ice particles and rocky debris, glittering brilliantly in sunlight. Saturn's density is lower than water's, meaning it could float on an ocean large enough to contain it. Uranus and Neptune belong to the ice giant category, their interiors containing vast quantities of icy substances like water, ammonia, and methane. Uranus's rotational axis is exceptionally tilted, almost lying flat as it rolls along its orbit. Neptune hosts the solar system's most violent storms, with wind speeds exceeding 2,000 kilometers per hour. Beyond Neptune's orbit, we enter a vast, frigid region of the solar system, the Kuiper Belt, a disc-shaped zone similar to the asteroid belt but vastly larger, composed of countless icy celestial bodies. Pluto stands as one of the most renowned members of the Kuiper Belt. Here lie preserved the most primordial frozen materials from the solar system's infancy, serving as a crucial source for short-period comets. Yet the Kuiper Belt is far from the solar system's boundary. In even greater distances, at approximately 10,000 astronomical units from the Sun, lies a theoretical vast spherical shell cloud, the Oort cloud, believed to be the birthplace of long-period comets. The Oort cloud's scope is so vast that its outer edge may extend to the very limit of the Sun's gravitational dominance, roughly 0.8 to 1.5 light-years from the Sun. This implies the true extent of the solar system nearly touches the sphere of influence of neighboring stars like Proxima Centauri. Within this vast, well-structured solar system, the Earth, this spaceship, is able to navigate in a relatively safe environment, largely due to an invisible escort force. At the core of this escort force stands Jupiter. With its immense mass, Jupiter generates an exceptionally powerful gravitational field, This gas giant plays a pivotal role as the solar system's gravitational sweeper. Its gravitational pull acts like a vast protective net, effectively attracting or deflecting numerous potential threats entering the inner solar system. When comets from the outer solar system, particularly those originating from the Kuiper belt or Oort cloud, plunge toward the inner solar system, Jupiter's immense gravity significantly alters their trajectories. Many comets are captured by Jupiter's gravitational pull, ultimately plummeting into its atmosphere to be destroyed, or accelerated by Jupiter's gravitational slingshot effect, and permanently ejected from the solar system. The most famous example occurred in 1994, when comet Shoemaker-Levy 9 was torn apart by Jupiter's gravity into 21 fragments. These fragments successively collided with Jupiter's southern hemisphere at 60 kilometers per second, releasing total energy hundreds of times greater than the combined global nuclear arsenal. The impact left a scar on Jupiter's surface larger than Earth, which persisted for months before gradually fading. Imagine if this comet had targeted Earth. The consequences would have been catastrophic. Jupiter's presence significantly reduces the probability of such celestial bodies colliding with Earth, providing a more stable cosmic environment for the emergence and evolution of life on Earth. Beyond Jupiter, other giant planets like Saturn, Uranus, and Neptune also contribute through their gravitational forces to maintaining the dynamical stability of the outer solar system. Together, they form a multi-layered planetary defense system. Moreover, the solar system's inherently sparse structure itself offers protection. The vast distances between planets make direct collisions between celestial bodies extremely rare. The relatively clean space environment of the inner solar system reduces the frequency with which Earth encounters interstellar debris during its journey. It is precisely this complete picture of the solar system, from the fiery core of the Sun to the frozen frontier of the Oort cloud, from the relatively mild environment of the inner solar system to the gravitational barrier formed by the giant planets of the outer solar system, collectively defines the local cosmic space occupied by Earth, this spaceship. We are not navigating a primordial nebula fraught with danger, but exist within a mature planetary system that has evolved over billions of years, possessing structured order and a degree of self-protective capability. Giant planets like Jupiter, silent guardians, have for billions of years used their powerful gravity to clear obstacles and defuse crises in the inner solar system. This has enabled Earth to maintain relative environmental stability throughout its long geological history, creating uniquely precious conditions for the emergence of life and the birth of civilization. Recognizing this, we marvel not only at the solar system's grand architecture, but also feel profound gratitude that Earth's spaceship possesses such formidable natural guardians. As we immerse ourselves in the vision of the solar system hurtling around the galactic center, a deeper cosmic truth gradually emerges. Our Milky Way is not an isolated island in the universe. It belongs to a gravitational family known as the local group. This is a crucial link in the cosmic address of Earth's spaceship. The local group is a relatively loose association of galaxies, with a gravitational influence spanning roughly 10 million light-years in diameter. At this scale, even traveling at the speed of light would take 10 million years to traverse from one end to the other. Within this group, two absolute dominators reign supreme: our own Milky Way and the Andromeda Galaxy. Andromeda, designated M31 in astronomical catalogs, it is a spiral galaxy larger than the Milky Way, with an estimated diameter of 220,000 light-years, and may contain over 1 trillion stars, far exceeding the Milky Way's scale of 200 to 400 billion stars. Beyond these two giants, The third most significant member of the local group is the Triangulum galaxy, also a well-defined spiral galaxy, though smaller in scale than the other two. Over 50 additional smaller galaxies are known, most of which orbit the Milky Way or Andromeda, as satellite galaxies. Examples include the Milky Way's famous large and small Magellanic Clouds, and Andromeda's companions M32 and M110. These satellite galaxies, like children beside giants, follow their parent galaxies step by step under the bonds of gravity. Although the local group possesses immense total mass, its internal spatial structure is remarkably sparse. The average distance between galaxies far exceeds the diameter of the galaxies themselves. The entire local group resembles a vast, sparse collection of stellar islands in the cosmos, loosely held together by shared gravity, and moving as a unified entity through the universe. Yet within this seemingly stable galactic family, a cosmic-scale event is brewing, one destined to unfold. Our Milky Way galaxy is drawing ever closer to the Andromeda galaxy, under the pull of mutual gravity, at a speed of approximately 110 kilometers per second. This velocity may not sound astonishing, but considering the immense masses of both galaxies, and the billions of years over which this interaction will unfold, the ultimate outcome is already predetermined, according to astronomers' most precise computer simulations. In approximately 3 to 4 billion years, the Milky Way and Andromeda will experience their first close encounter. Note that this is no simple brush past. Due to gravitational tidal forces, the spiral arm structures of both galaxies will be severely twisted and stretched during this encounter. Viewed from the distant cosmic perspective, they resemble two vast luminous fluids, performing an elegant yet deadly duet under gravity's command. After their initial encounter, the two galaxies will not simply drift apart. Like dancers who brush past yet remain drawn to each other, they will spiral back toward one another under gravity's pull. After several cycles of approaching and separating, they will ultimately merge completely into a new galaxy approximately 6 billion years from now. Astronomers call this process a galaxy merger. The final product is typically a massive elliptical galaxy. In the early stages of the merger, the cores of the two galaxies gradually draw closer. The supermassive black holes at the centers of the Milky Way and Andromeda will begin orbiting each other, and eventually merge into an even more colossal black hole. This black hole merger will release intensely powerful gravitational waves, rippling through the fabric of space-time. Yet for us aboard the Earth spacecraft, the direct experience of this cosmic-scale collision may prove far less terrifying than it sounds. Due to the extremely sparse distribution of stars within galaxies, the probability of two stars colliding directly during the merger is minuscule. Our solar system and the Earth spacecraft have a high probability of being gravitationally ejected into a new orbit. Will likely be gravitationally ejected into a new orbit, while surviving unscathed. Yet viewed from Earth's night sky, the spectacle will be breathtaking. Over billions of years of merging, the Andromeda galaxy's apparent size in the sky will grow progressively larger, until it fills the entire celestial dome. Twisted stellar streams and newly formed starbirth regions will illuminate the night sky with unprecedented brilliance and splendor. Should any observers remain on Earth by then, they will witness a brand new unified galactic radiance enveloping their world. This impending collision and merger profoundly reveals the dynamic nature of the cosmos. Galaxies are not eternal, static islands. They grow, evolve, and expand their scale. Through mergers, our own Milky Way galaxy has attained its immense size precisely by devouring and merging. countless smaller satellite galaxies over the past 10 billion years. Earth, this cosmic vessel, navigates not only with the Sun through the Milky Way, but also with the Milky Way itself within the local group, heading toward a predetermined future of merging with its neighbors. This transforms our understanding of the universe, from a static tableau to a dynamic evolutionary epic. We are currently in the early chapters of this grand cosmic drama. To comprehend the ultimate cosmic destination of Spaceship Earth, we must first establish an absolute reference frame, a coordinate system stationary relative to the entire universe. This coordinate system does not exist in a void. It is imprinted upon the universe's oldest light, the cosmic microwave background radiation. The cosmic microwave background is the lingering glow of the Big Bang, born approximately 380,000 years after the universe's creation. At that time, the fiery, dense primordial universe had cooled sufficiently for atoms to form, and photons to travel freely through space. After over 13 billion years of journey and redshift from cosmic expansion, filling the entire observable universe as we know it today, its temperature has dropped to 2.725 degrees Celsius above absolute zero, exhibiting a nearly perfect blackbody radiation spectrum. Discovered accidentally by Penzias and Wilson in the 1960s, it is hailed as definitive evidence for the Big Bang theory. If the universe were perfectly uniform and isotropic, the cosmic microwave background radiation should be completely uniform in all directions. Early observations seemed to confirm this. However, as measurement precision improved, scientists discovered a puzzling phenomenon. The cosmic microwave background radiation is not strictly uniform. It exhibits extremely subtle anisotropies, the largest of which is known as dipole anisotropy. Specifically, in one particular direction in the sky, the temperature of the cosmic microwave background radiation is slightly higher than the all-sky average by about 1,000th. Conversely, in the direction directly opposite to this, the temperature is slightly lower by the same amount. This temperature distribution pattern perfectly matches the effect expected by an observer moving through the universe. It is precisely a cosmic scale Doppler effect. When we move in a certain direction, the frequency of cosmic microwave background photons coming from that direction is slightly increased due to our motion, manifesting as slightly higher temperatures. This is known as blue shift. Conversely, photons originating from behind us experience a slight frequency decrease, resulting in slightly lower temperatures. This is termed red shift. By precisely measuring the magnitude and direction of these temperature fluctuations, astronomers can infer the velocity of our solar system relative to the static reference frame of the cosmic microwave background radiation. Calculations reveal our Milky Way is moving at an astonishing speed of approximately 600 kilometers per second toward the region where the constellations Hydra and Centaurus meet. This velocity far exceeds the Sun's orbital speed around the galactic center. This implies that the Milky Way's own overall motion, its proper motion velocity, dominates the signal we observe in the cosmic microwave background radiation. This discovery fundamentally transforms our view of the universe, proves that the Milky Way is not leisurely wandering alone through space, but is instead being dragged along by a powerful force, on a purposeful, high-speed voyage. So what force could possibly propel an entire galaxy at such immense speed? The answer to this question points toward our ultimate destination, a mysterious gravitational abyss hidden deep within the cosmos, a supermassive gravitational source. This supermassive gravitational source is not a single celestial object, like a supermassive black hole, but rather an immense region of gravitational anomaly, a cosmic-scale mass concentration center. Its location lies approximately 150 to 250 million light-years away, at the core of the Laniakea supercluster, behind the constellations of Hydra and Centaurus. Since this direction coincides with the dust lane of the Milky Way's disk, massive amounts of interstellar gas and dust block our view, making it difficult for optical telescopes to directly observe the cosmic structures behind it. This shrouds the great gravitational anomaly in mystery. Astronomers refer to this region as the hidden belt. Though we cannot see it directly, we can perceive its presence by studying the large-scale motions of galaxies. During the 1970s and 1980s, scientists mapped the three-dimensional distribution of galaxies in the local universe. By observing the redshifts and distances of thousands of galaxies, they were astonished to discover that across a vast span of hundreds of millions of light-years, including our own local group, the Virgo supercluster and thousands of other galaxy clusters, all exhibited a common, coordinated flow pattern. All these galaxies seemed swept along by an invisible cosmic current, moving in the same direction, toward the location of the Great Attractor. This immense flow engulfing countless galaxies is termed the galactic proper motion flow. By analyzing the flow's velocity and distribution, astronomers estimated the supermassive source's immense mass, potentially equivalent to tens of thousands of Milky Way galaxies, or roughly 100 trillion solar masses. Such colossal mass concentrated within a relatively confined cosmic space generates gravitational forces powerful enough to influence matter's motion across hundreds of millions of light-years. Our Milky Way is but a small vessel in this cosmic torrent, firmly captured by the supermassive black hole's gravitational pull, approaching it at 600 kilometers per second, a velocity 2.7 times faster than the Sun's orbit around the galactic center. At this pace, it will take us billions of years to draw nearer to this gravitational center. Notably, we are not plummeting straight toward the supermassive black hole. Due to our immense lateral velocity, the Milky Way will ultimately complete a prolonged orbit within the supermassive black hole's gravitational field, rather than colliding directly into its core. More significantly, the supermassive black hole itself is not the ultimate destination in the cosmos. Subsequent observations and research have unveiled a more expansive cosmic panorama. The Laniakea supercluster, within which the supermassive black hole resides, is itself influenced by the gravitational pull of even more distant cosmic structures. For instance, the gravitational pull of the equally massive Shapley supercluster. This implies our cosmic journey is an endless relay race, sliding from one gravitational well into another, participating in the grand restructuring and cycling of matter and energy that has never ceased since the universe's birth. The discovery of dipole anisotropies in the cosmic microwave background radiation is like providing us with a cosmic navigation map. It reveals the Milky Way's true motion within the cosmos. Tracing the source of this motion confronts us with the Great Attractor, the cosmic gravitational anchor, governing the motion of our supercluster. Earth, this spaceship, carries us along the Milky Way's torrent, across this cosmic web woven of gravity and matter, on an epic voyage spanning billions of years. As our exploration of cosmic structures deepens, astronomers realized traditional galaxy cluster classifications could no longer describe the grand connections galaxies exhibit across hundreds of millions of light-years. In 2014, an international team of astronomers led by Brent Tully and Hala Kuchar, based on precise analysis of galaxy proper motions, mapped an unprecedented three-dimensional cosmic landscape. They uncovered a breathtaking superstructure and named it the Laniakea supercluster. Laniakea, meaning endless heaven in Hawaiian, aptly describes the boundless expanse of this cosmic continent. The scale of the Laniakea supercluster defies human intuition. Its astonishing span reaches 520 million light-years. Within this vast volume reside at least 100,000 galaxies like our Milky Way. Its total mass equals approximately 10 superscript 1 solar masses. To traverse this cosmic continent, even at the speed of light, would require over 500 million years of flight. The supercluster's shape is neither a simple sphere nor ellipsoid. Viewed from the perspective of the large-scale structure of the universe, it resembles a vast cosmic leaf, or an extraordinarily complex neural network. Its structure is woven from countless filamentary strands composed of galaxies. These galactic filaments encircle relatively sparse cosmic voids, forming a porous, networked, foam-like structure. Astronomers vividly describe this structure as the cosmic web. Laniakea represents an exceptionally massive node and junction within this cosmic web. Within Laniakea, galactic motion is not chaotic. They all follow a common trend, flowing toward the gravitational center of the entire supercluster. This gravitational center is precisely the mysterious destination we mentioned earlier, the Great Attractor. We can now describe it more precisely. The Great Attractor is not a solitary, extremely dense point-like object, such as a supermassive black hole, while its central region may contain a massive galaxy cluster. The Normgurikler galaxy cluster, the Great Attractor itself, is an extremely extensive gravitational potential well. It is a vast region of gravitational anomaly, whose influence extends across most of Laniakea. Imagine Laniakea as a colossal gravitational basin, with the Great Attractor as its absolute lowest point. Just as water flows downward, all matter within this gravitational basin, including our own Milky Way galaxy, naturally drifts toward this lowest point. This is the ultimate source of the proper motion velocities we measure. Our position in the universe can be precisely mapped through a hierarchical address system. We live on the planet Earth. Earth is the third planet in the solar system's orbit. The solar system resides within the inner part of the Orion arm of the Milky Way, at a distance of approximately 26,000 light-years from the galactic center. The Milky Way, along with over 50 other galaxies such as the Andromeda Galaxy and Triangulum Galaxy, collectively form the local group. The local group as a unified entity, a constituent part of the Virgo supercluster. The Virgo supercluster itself is merely a slender branch of the Laniakea supercluster, like a small stream flowing into a vast river. On the cosmic map of Laniakea, our Milky Way is not at the center, but rather at the end of a galactic stream leading toward the Great Attractor, a relatively peripheral zone. Astronomers vividly describe this location as the cosmic suburbs. As we gradually zoom out from Earth's perspective, a clear hierarchical nesting structure emerges. Earth is part of the solar system. The solar system is part of the Milky Way galaxy. The Milky Way galaxy is part of the local group. The local group is part of the Virgo supercluster. And the Virgo supercluster is ultimately part of the vast cosmic continent known as Laniakea. Each successive level is tens or even hundreds of times larger than the one before it. Recognizing our place within the Laniakea supercluster instills a profound sense of cosmic humility. On this cosmic continent containing 100,000 galaxies, our Milky Way is merely an ordinary member. Our solar system is but one among the Milky Way's hundreds of billions of stars. Our Earth is but a tiny planet orbiting this star. The human civilization that has evolved on this planet appears, from the cosmic perspective, both incredibly small and yet profoundly precious. The discovery of the Laniakea supercluster not only provides us with a cosmic address, but also allows us to intuitively grasp the structural beauty and dynamic essence of the universe. It reveals the sculptural work of gravity over billions of years, revealing how matter, following the Big Bang, through gravitational instabilities, coalesced into filaments of galaxies and cosmic voids, forming the magnificent cosmic web we observe today. Earth, this spaceship, carries us across this boundless cosmic web, swept along by the torrent of galaxies, on an eternal voyage through space and time, and Laniakea is the grandest backdrop to this journey we currently comprehend. Our journey tracing Earth's trajectory has reached the Laniakea supercluster. Yet this is far from the story's conclusion. It marks merely the beginning of a grander narrative chapter. This vast cosmic continent of Laniakea itself does not hover motionless in the void. It too is a moving node within the cosmic web, engaged in an eternal voyage without end. Astronomical observations reveal that the Laniakea supercluster as a whole is gravitationally influenced by larger-scale structures in the cosmos. The most significant influence stems from the Shapley supercluster, one of the largest mass concentrations currently known in our universe. Located along the extension of Laniakea, this implies that our cosmic continent is like a river flowing into a greater ocean current, moving with the overall flow of cosmic matter. This motion carries us into a realm of awe-inspiring understanding. On the scale of the observable universe, matter exhibits a hierarchical fractal network structure. Galaxies cluster into groups. Groups connect into superclusters, and superclusters in turn form cosmic filaments and walls spanning billions of light years. Between these colossal structures lie vast, nearly void cosmic voids. Earth, this spaceship, resides at a tiny node on this boundless cosmic web. All our movements, from rotation to our mad dash toward the gravitational source, are but a local glide across this dynamically shifting cosmic network. This voyage inherently possesses neither origin nor destination. It traces its origins to the Big Bang 13.8 billion years ago, to the minute quantum fluctuations within the primordial universe. Through billions of years of gravitational amplification and sculpting, it has formed the magnificent structures we observe today, driving all celestial bodies in ceaseless motion within them. All motion is relative. All stillness is an illusion confined to scale. As we gradually zoom out from Earth's perspective, we perceive a distinct hierarchy of nested scales. Earth rotates on its axis. Earth orbits the Sun. The Sun leads the solar system in its rapid journey around the Milky Way's center. The Milky Way approaches the Andromeda galaxy within the local group. The local group drifts toward the Virgo supercluster toward the Great Gravitational Anomaly. The Laniakea supercluster moves as a whole toward the Shapley supercluster. And all of this is embedded within the grand backdrop of cosmic expansion and the flow of matter. Each level is governed by the gravitational environment of the level above it, while simultaneously forming the foundational framework for the motion of the level below. The essence of Earth within this panorama is a tiny spacecraft embedded within layers of nested, massive motion structures. It simultaneously undergoes multiple motions in different directions and at different speeds. These motions, superimposed upon one another, form its complex yet deterministic trajectory through the cosmos. We humans and all the civilizations we have created exist aboard this spacecraft. Our history, our art, our science and exploration, all unfold within this tiny vessel, traveling at astonishing speeds through the indifferent cosmos. Recognizing this makes us feel both our own insignificance and contingency, and the preciousness and uniqueness of our existence. In the boundless universe and eternal time, this spacecraft and its crew are granted in fleeting moments a glimpse of the grand patterns and magnificent structure of the universe's workings. This alone is a miracle worthy of wonder. Our voyage has no predetermined destination, nor a final harbor. It is in itself a state of being, an inevitable manifestation under the laws of cosmic dynamics. Earth, this spaceship, will continue its journey, following the rhythm of the universe, sailing into the unknown depths of time and space. Now, as we turn our gaze back to the planet beneath our feet, what we behold is no longer a static world, but a spaceship carrying all of human civilization and the history of life. With a series of awe-inspiring compound velocities, it navigates resolutely through the cold, empty expanse of interstellar space. Let us review one final time the astonishing hierarchy of speeds encountered on this journey. On Earth's surface, we move with the planet's rotation, traveling at 1,670 kilometers per hour along the equator. This velocity allows us, completely unaware, to complete a full circumnavigation of the globe each day. When Earth revolves around the Sun, our speed surges to 29.79 kilometers per second, covering over 2.5 million kilometers daily in orbit, a velocity sufficient to reach the Moon from Earth in 10 minutes. Yet this is merely our cruising speed within the solar system. When we realize the Sun propels our entire solar system at 220 kilometers per second around the Milky Way's core, our journey gains a grander scale. This velocity exceeds Earth's orbital speed by over 7-fold, enabling us to witness, over the 250 million-year galactic year, the birth and death of stars alongside the evolution of galaxies. Yet the ultimate velocity of this voyage stems from the Milky Way's own migration toward the Great Attractor. This terminal velocity of 600 kilometers per second is 2.7 times the Sun's orbital speed around the galactic center. It propels our spaceship through the gravitational field of the Laniakea supercluster, on a magnificent journey spanning hundreds of millions of light years, from Earth's rotation at less than half a kilometer per second, to the galactic migration at 600 kilometers per second. Earth's simultaneous participation in these motions composes a layered, sweeping cosmic odyssey. Within this epic, Earth's spacecraft reveals its dual nature of extreme preciousness and fragility. Across the known cosmos, we have yet to discover a second planet resembling Earth. It occupies the habitable zone of its star system, maintaining a perfect distance from its parent star that keeps Earth's surface temperatures within the range where liquid water can persist. Possesses a moderately thick atmosphere, which not only provides the oxygen we need to breathe, but also acts like a warm blanket, maintaining suitable surface temperatures through the greenhouse effect. Simultaneously, it functions as a sturdy shield, shielding it from most asteroid impacts and harmful cosmic radiation. Earth's magnetic field acts as an invisible force field, deflecting high-energy charged particles from the solar wind, and preventing the atmosphere from being gradually stripped away. Much like Jupiter protects the inner solar system, Earth's own systems form a delicate equilibrium. Its crustal movements, through volcanic activity and mountain-building processes, sustain the carbon cycle and material regeneration. Its hydrological cycle, through evaporation, precipitation, and rivers, distributes heat and nutrients globally. All these conditions, over billions of years, have come together in perfect harmony to transform Earth from an ordinary rocky planet into a vibrant world teeming with life, a cosmic ark providing unique refuge for us and millions of other species amidst the violent cosmos. Yet this precious vessel also reveals alarming fragility. Though robust, its life support systems are not invincible. As passengers and stewards aboard this vessel, we humans are now exerting unprecedented pressure on its ecosystems through our activities. Our massive burning of fossil fuels releases excessive carbon dioxide and other greenhouse gases into the atmosphere, altering Earth's atmospheric chemistry, intensifying the greenhouse effect, causing a persistent rise in global average temperatures, triggering polar ice cap melt and sea level rise, along with increased frequency and intensity of extreme weather events. For agricultural expansion and urban development, we are conducting large-scale deforestation and wetland destruction, leading to habitat fragmentation and loss. Countless species are heading toward extinction at rates far exceeding natural background levels. The precipitous decline in biodiversity is undermining the very foundations of Earth's ecosystem stability. We overexploit groundwater resources, pollute rivers, lakes, and oceans, discharge chemicals and plastic waste into natural environments. These pollutants accumulate along the food chain, ultimately returning to ourselves, impairing the health of humans and other living beings. The impacts of these human activities intertwine and amplify, collectively posing severe challenges to Earth's life support systems. We resemble a crew of short-sighted sailors, unwittingly dismantling the spacecraft's bulkheads for fuel, polluting the recycled water purification systems, and destroying the environmental control units that produce oxygen. When we reconsider this spacecraft and its insignificance and isolation on a cosmic scale, we must confront a harsh reality. In the foreseeable future, we possess no second spacecraft to migrate to, no cosmic port to dock at. Earth is our sole home, our only base for survival and development. In this endless cosmic voyage, only by recognizing this can we deeply understand that protecting this spacecraft is not merely a moral choice, but a survival necessity determining the continuation of human civilization. In the following chapters, we will explore what mission we, as crew members of this spacecraft, bear, what mission we bear, and how we must act to ensure this precious cosmic vessel continues carrying the hope of life and civilization, safely navigating the vast sea of stars. After examining the grand trajectory and fragile nature of Earth, this cosmic ship, an unavoidable question confronts us. What role do we humans play aboard this vessel? Most other life forms on Earth are merely passengers aboard the ship. They survive and evolve according to natural laws, passively adapting to the ship's environmental shifts. Yet we humans are fundamentally different. Endowed with self-awareness and wisdom, we comprehend the ship's operational principles, foresee potential crises, and actively alter the ship's internal environment. This transforms us from mere passengers into crew members of this vessel. We bear a unique responsibility unshared by other species. At the core of this duty lies guardianship. Safeguarding the Earth spacecraft's ecosystem is safeguarding the very foundation of our civilization's survival. We must maintain Earth's life support systems with the same meticulous care an astronaut maintains a space capsule. This means managing the spacecraft's resources, fresh water, soil, forests, and oceans, in a sustainable manner. We must reduce our dependence on fossil fuels and accelerate the transition to renewable energy to stabilize the spacecraft's atmospheric composition and temperature. We must protect biodiversity and safeguard every link in the intricate ecological web, for the absence of any key species could destabilize the entire system. We must develop a circular economy to minimize waste generation and enable efficient resource recycling within the spacecraft, reducing the environmental footprint. This responsibility of stewardship is not solely the task of scientists or politicians. It is the shared mission of every crew member living aboard this spaceship. from reducing energy consumption to practicing waste sorting, from supporting sustainable products to protecting the natural environment around us. Every small action contributes to the overall health of the spaceship. Yet stewardship does not mean confining our gaze solely within the spaceship. Quite the contrary. To better safeguard our home, we must courageously venture beyond the spacecraft. Space exploration is not a luxury adventure, but a profound extension of our crew responsibilities. Its fundamental significance lies in providing us with the ultimate external perspective to examine Earth. When astronauts gaze back at this blue planet from space, they profoundly realize Earth is a solitary oasis of life in the vast cosmos. Borders cease to exist. Only a fragile atmosphere envelopes all oceans and continents. This perspective reveals that all humanity are crewmates sharing a common destiny aboard this spaceship. Space exploration is also our essential lesson in learning how to safeguard the vessel. On the International Space Station, we study how to recycle water and air within a closed environment. These technologies can be directly applied to improve resource management on Earth. Through material science and life science research in microgravity, we gain knowledge unattainable on Earth, which may spark new technological and medical breakthroughs. By observing Earth's oceans, forests, and atmosphere, we precisely monitor global climate change, glacial melt, and pollution levels, providing critical scientific data for safeguarding our spacecraft. Deep space exploration deepens our understanding Earth's position and circumstances within the cosmos. Studying Mars reveals a world stripped of its global magnetic field and its atmosphere, now cold and dry after being stripped away by solar winds. This serves as a stark reminder of how vital Earth's magnetic field is for our protection. Observing Venus shows us how runaway greenhouse effects can transform a potentially habitable planet into a hellish surface hot enough to melt lead. This sounds an alarm for us to address global warming. By observing exoplanets, we are cataloging other potentially habitable worlds within our galaxy. This, in turn, deepens our appreciation for Earth as the only known planet currently sustaining life. Developing space technology itself also propels our ability to address Earth's crises. More efficient solar panels, more precise global navigation systems, more powerful computing and communication technologies. These innovations born from space exploration have been widely applied on Earth, improving the lives of billions, and provide new tools for tackling environmental challenges. More importantly, space exploration ignites humanity's curiosity and spirit of discovery. It inspires generations to study science, engineering, and the arts. It elevates our species beyond mere survival, to contemplate our meaning within the cosmos. This upward-reaching spirit is the intrinsic force propelling civilization forward. As crew members aboard Spaceship Earth, our mission is twofold. Internally, we must apply our utmost wisdom and effort to safeguard the intricate and fragile web of life within the vessel. Outwardly, we must explore the vast cosmos beyond the ship with eternal curiosity and courage, drawing knowledge and inspiration to better understand our home and learn how to preserve it for longer. Preservation and exploration are not mutually exclusive. They are two sides of the same mission, both aimed at ensuring human civilization can continue its long and hopeful interstellar journey. Voyage. Now, please find the most comfortable position and relax your body. Slowly close your eyes as we draw our thoughts back from the boundless depths of the cosmos, from the spiral arms of the Milky Way, from the frontiers of the Laniakea supercluster, back to this planet that bears us in this very moment. Feel the solid, warm earth beneath you. This is the deck of our cosmic spaceship. It has sailed through the sea of stars for 4.6 billion years, witnessing countless births and deaths, bearing the weight and dreams of all human civilization. Imagine Earth's spaceship now, gliding at those astonishing speeds we've just learned, gliding in absolute silence. Its motion is so smooth, we scarcely sense the furious dash unfolding. Beyond the window lies eternal night, dotted with distant starlight. Within the cabin lies our only home, filled with air, water, and the pulse of life. In this known universe, no other place offers such refuge. Your breath right now is connected to the Earth spacecraft's life support system. Every breath you inhale has been meticulously calibrated by billions of years of evolution. The warmth you feel comes from the precisely tuned greenhouse effect and the perfect distance from the sun. Slowly focus your attention on your breath. Feel how the air flows in and out naturally, just as Earth moves effortlessly along its orbit. No effort is needed. No control is required. Everything flows freely within the cosmos's laws. Now reflect on all we've learned tonight. From Earth's rotation to the Milky Way's migration. From minuscule atoms to colossal superclusters. All motion follows unified principles. All existence is interconnected. Against this backdrop, consider your personal worries and anxieties, those daily fears and unease, those uncertainties about the future, those regrets from the past. They remain real, yet on the cosmic scale, they gain new perspective. Like distant stars in the night sky, they exist, but no longer dominate the entire view. You can gently set these thoughts aside. Imagine them as interstellar dust, guided by gravity, drifting slowly into the distance, no longer troubling your heart. Feel the steadiness of Earth, this spaceship. It has weathered 5 mass extinctions, endured the bitter cold of ice ages, withstood asteroid impacts, yet it remains stable in its orbit, still nurturing new life. As passengers aboard this vessel, we inherit this resilience. Through long evolution, our ancestors overcame countless challenges to pass the torch of life to today. This very spot where you lie, this room, this bed, is a unique coordinate in the cosmos, a miracle forged through billions of years of evolution, a place that exists by the grace of time. Listen to your steady breath. Feel the rhythm of your heartbeat, the oldest melody of life, as constant as Earth's rotation, as timeless as the star's journey. Imagine our Earth ship, gliding silently through the vast cosmos, like a vessel sailing an endless ocean, carrying all life, carrying all dreams, steering steadfastly and serenely toward the future. You need not control anything, need not change anything, just as Earth requires no deliberate effort to maintain its orbit, just as the Milky Way needs no guidance to find its course. Everything flows naturally. Everything resides in its rightful state. Let this realization bring you profound peace. We are both insignificant and precious, both transient and eternal components. On this tranquil night, you are connected to the entire universe, to 13.8 billion years of history, to hundreds of billions of galaxies. And in this moment, all you need to do is let yourself completely relax, completely trust this spaceship, trust the natural laws of the cosmos. Feel the bed supporting your body, just as Earth sustains our civilization. No effort is needed. Simply embrace this support completely. Each breath you take resonates with this planet's rhythm. Each heartbeat syncs with the pulse of the cosmos. Now let your awareness slowly fade, like distant starlight, gently merging into this tranquil night sky. Entrust yourself wholly to this moment. Surrender to the spacecraft sailing safely through the cosmos. In this boundless universe, on this special planet, in this unique moment, you exist safely, guarded, carried. Let sleep be like gentle interstellar matter, softly enveloping you, guiding you into deep rest, where there is no anxiety, no boundaries, only the tranquility of pure being. Good night, our precious Earthship. Good night, our courageous cosmic crew. May you find the deepest peace and the most tranquil dreams under the protection of this starry sea. Now, let yourself fully immerse in this cosmic-level tranquility. Slowly drift into dreams, just as Earth glides in its orbit, safely toward a new dawn.